No.
You're 1 minute early, I guess.
Yeah.
Awesome. Thanks for having me.
Yeah.
Thanks for coming, man.
Mm.
Yeah, so I figure I'll keep it super informal, and we can talk about pretty much anything. And if I get totally in the weeds and I have no idea what I'm talking about, I'll just let everyone know.
It's what we end up doing here anyways.
Awesome. So how about you guys actually tell me a little bit about this group because I've had it on my radar. I've seen the Twitter account and I've obviously joined this Discord. Haven't had a chance to really like poke around. I'm curious what sorts of folks you guys are. Um,
Well, it started when Leslie said, "Hey, I want to start a graphics programming meetup group." And I said, "Cool." So that's just kind of how it started. And most of us are, I don't want to say amateurs, but we're not all big wigs in the industry or anything. We're just having geeks interested in stuff, and we end up covering what we think is interesting every week. You know, a couple of weeks ago we did the Elden Ring frame analysis because we saw the article of that and said we want to read through that. So, you know,
that's awesome. This group is awesome. Like I looked over the meetup agenda for like the like prior sessions as well, and I was like just generally impressed with how enthusiastic everyone in this group is in terms of like just pursuing new resources and learning things. And it's cool that you guys have formed this. Like, I think
hmm
when I originally started, like way back before shaders even existed, like I didn't really have anyone to really talk to about what I was trying to build or doing. So this is great. I would have appreciated this when I was learning.
I'm consistently blown away by what everyone here does. I keep seeing posts in the different channels as well as what people present on, and I'm just like, damn.
Yeah, that's awesome. I mean, I'm probably going to learn from you folks.
I certainly learned a lot. I mean, I'm no graphics programmer, and this past year of really, I appreciate this group a lot. Let's just say that.
Yeah, that's
For me,
awesome.
like
Well,
my day
hmm?
job is not graphics related, so and it's a passion, so it's really awesome to have an opportunity to discuss it with people.
That's great. Now, is that true for many people here? Like people are just interested in graphics, but not necessarily doing graphics professionally yet? Or are there some folks that are also doing it professionally as well?
Oh yeah, my
Yeah,
job
it's not my
is
day job either.
Some of us work full time in graphics, such as myself and Charles.
I was gonna throw I was gonna throw JB under that bus and not and exclude myself specifically because I don't get to do graphics stuff. I tend to be very adjacent.
yeah,
Close enough.
my job is mostly shaders. Yeah.
I think JB's trying to say something.
Oh yeah, that's 100%.
No, I was just listening. In terms of the folks that are in graphics or interested in graphics, I'm curious, are people generally interested in games or in film or something else, maybe like automotive or simulation or something?
I work in games, so games for sure.
Okay, that's what I'm most familiar with, so that's good.
I think most people here are, if they have a job in the graphics thing, it's games oriented.
Mm-hmm.
Yeah, I'm
Yeah,
I'm more
that's
on the simulation
Ooh,
visualization side,
that's cool.
okay.
and I also mod Chronos for GLTF format as well.
Oh, awesome. Yeah, that's good stuff. I mean, I've only more recently in my career been exposed to things outside of games. Like game engines, obviously, are starting to take hold not just in like simulation and stuff, but also in the VFX world, where you guys probably have seen like things like Mandalorian using Unreal Engine. Um, And Amazon, which is where I work currently, they also have some investments in like virtual production because like Amazon Prime Video and all that. So um, have been thinking a little bit more about that space as well, which has other challenges. I did mention also Mandalorian no longer uses Unreal for like the actual live shoots. They reverted back to the Helios real-time render that ILM builds, but they still use Unreal for like previs and virtual scouting and a number of other workflows there. All that is to say, VFX is still not an industry that I know the most about. I know some, but not a ton. More than happy to try to help if people are interested in that area.
So it's about time we start getting to the main meat of this. And the thought I had was this was kind of a Q&A session with 9points here. I don't have any strict rules or anything about the topic or whatever, and it sounds like 9points is equally laissez-faire. However, I think people should be trying to ask their questions in voice, and if we could try to keep back some of the tangential stuff so that we can get through more questions rather than get sidetracked. Because as a group, you're very easily distracted, and we'll find an interesting topic and just keep talking about it, but we do want to try to let people who have questions ask them. It's fine to post the question in chat. That way, there's like a record of them if you want. But I'm just gonna let people go right at it.
Okay, sounds good. And people can refer to me as Jeremy too, by the way.
Oh. Hello, Jeremy.
Hey.
All right, I'll ask a question. So, you work at Amazon, but what's your position at Amazon or your role? I didn't see it
Yep.
when I took a look at your website.
Yep, I can talk about a little bit about my current role. So I'm a principal engineer here at Amazon, and the group that I help lead is the rendering group that works on the Open 3D engine. So the Open 3D engine is something that released relatively recently, so it's a pretty new project. It's been out there for I want to say like half a year, and it's still like technically really in a developer preview mode. Prior to Amazon working on this engine, I was working as a principal engineer at Warner Brothers, also like largely focused on graphics. So Warner Brothers was a little bit different than my current role in that that publishing group has an amalgamation of different studios that they've acquired over the years, some of which use Unreal engines, some of which use custom engines, etc. So I got a lot of exposure to like different engines and different rendering paradigms and all that. Yeah, so hopefully that gives a little bit of a background on my current role, my past role. Before that, I've largely been working in and out of graphics. So
Are you in LA or somewhere else?
I'm actually currently based in Colorado.
Okay.
The team is very distributed though, like throughout Seattle, and there are some folks in LA, there's some folks in Irvine, some folks in Texas and the UK. Actually, the job that I had before was also very distributed, so I ended up having to travel a lot, which is odd for a graphics engineer, I suppose.
Yeah, the O3D engine's open source, and yeah, I haven't checked it out, but it looks pretty interesting.
Yeah, and in fact, like I can even let me just dig up some random thing that I wrote. Because it's open, a lot of the things that I write in there, like this is an example I'll just post in the general chat of one like design discussion thing that I started just a few days ago, and there's plenty of other like pull requests and other things that I did. Not everything that I do is like attached directly with this public repository. Obviously, there are some things that I work on that I can't directly share, but this is one perk of working on an open source product is that there are some things I can share.
I'm looking at this.
Yeah, like maybe
Buffer
I'll share like one other initiative that I've been trying to advocate for. This particular discussion forum is somewhat bare. It doesn't have a lot of stuff there because it's kind of new. We weren't really using it before the last month or so.
I heard Epic has started to join with like in a way like maybe funding or something with O3D engine. Is that right?
Yeah, so they joined as a partner with the foundation. I think that was announced a week ago, and it's interesting. Like, obviously, I can't say exactly what their intentions are. You know, they're an entirely different company and everything like that. But I know that Epic generally has been very interested in making their engine very interoperable, adhering to open standards in general. So, like someone mentioned, GLTF and Kronos earlier, for example. There's also the Pixar group with their technologies like USD and PTEX and all that kind of stuff. And so O3DE also being open source, also wanting to develop and integrate with open standards. I think from that perspective, it made sense to kind of like join forces because, as I'm sure many of you know, like 3D asset management and content management is just like a giant problem space. You could be very gainfully employed doing nothing but just wrangling asset pipelines and solving the various problems in that space. So
Isn't that just tech art? I feel like there's names for people who spend their careers doing that.
yeah, for sure. I mean, I imagine that not all tech artists necessarily enjoy that job, but yes, like if you're a tech artist and your weapon of choice is Maya or or Blender or whatever it happens to be, Houdini, etc. Like a good part of your day goes into thinking about like, you know, how do I get this data into a pipeline that our engine, whatever engine I happen to use, can readily ingest. And more than that, like you're one tech artist, but you're probably working with, you know, an army of other artists that you support along with other tech artists that you collaborate with. So there's the collaboration issue. You can't all be authoring the same asset and making modifications and everything at the same time. You need some way of structuring your data. When you split your data apart, you lose some efficiency. So you need some way of packing it back together or reconsolidating things. You need to make sure that your pipeline is robust when things go out of date. You need to have some mechanism to provide feedback on assets as they come in. So like in general, it's a very multifaceted problem. Like it's easy for us to just kind of like distill it down to, you know, it's just asset ingestion. But in reality, it's like a web of problems that kind of spiral from that workflow.
Yeah, that's a lot of problems are in the asset, and I mean in the past it was even crazier, right? When everybody kind of wrote their own thing from the ground up. But at least there's some standards now.
Yeah, they're starting to emerge. Like, you know, things like Material X, I'm pretty hopeful for, and it will always just be difficult because on the one side you have like, you know, film and artists, they want to work with quads, right? Because quads permit better and easier topology and stuff like that. And they want to work without UVs. They want like, you know, PTEX and UDIMs and ways of working with like textures that are very quick to iterate on. But those asset formats tend to perform very poorly. They're really expensive to load. They have really big data footprints on disk, etc. And so you need some like you will need some lossy conversion to something that your game can run on whatever platform you ultimately need to target. So I don't think any standard or any individual has yet like perfected how to map a set of content across that spectrum of fidelity quite yet. But we're getting there.
In your day to day, do you often have to, or not often, but at all have to be in contact with gameplay mechanics? Or do you just work on graphics and that's it?
Less so in my current role for sure, because my current role, graphics is used in a slightly more like generalist way than before. Certainly, when I was working on a game team, though, I had to think about those things a little bit more. Because you're thinking about things like if you're working on an open world game, for example, like loading and stuff, like you're thinking about like transitions between levels and how things are structured. In some cases, lighting and gameplay actually tie together. So I'll give one example was I think several titles ago, I worked on a system to feed back luminance into gameplay scripts so that they could do things like have a person automatically cast a spell that would like light the adjacent room if it got too dark, or like turn on a light switch as an example, turn on a flashlight. So those things will happen. In other cases, rendering gameplay an important, connective role. I think I recently watched a talk where the wind system used to drive the foliage was actually used to kind of direct the player where to go as a sort of like pathing system that wasn't just arrows on the map or whatever. It was actually something more integrated with the environment. I will say, as a graphics engineer, I'm generally never really like implementing the gameplay scripts or implementing the gameplay aspects that go into that. I will be more likely collaborating with the technical gameplay designer on like what the requirements are, and I'll come up with like a more general system that can service those requirements, and then build that so that that person feels like enabled to build whatever feature it is that they need.
So in an engine that is kind of open for something like O3D, something specific like that is implemented as a plugin, as a one-off, because not every game is going to need that, right?
So O3E happens to be kind of like a more monolithic, like all-in-one solution. You've got your renderer, it comes with physics, it comes with an editor, so you can put together your scene graph, your asset system, so you can bake textures depending on how you want it. It has its lighting systems, networking components, so it can do multiplayer. It is really just a full package. Obviously, you have projects like BGFX and other renderers that are out there that are just a rendering component. You kind of have to bring your own engine, like the rest of it. That wasn't really how this engine was built, because originally the roots of this engine were CryEngine, which then got forked to Lumberyard, which then got forked again to its current incarnation, which got open source early this year or late last year.
I guess I'm more asking about like the work, like the wind example that you gave, in the context of the engine. How was that actually executed? Was it through like a plugin? Because the engine's kind of a side thing, and then you got the gameplay programmers to implement.
Yep.
Yeah. So was it like
Yeah.
organized
So
in
you
that way?
could absolutely do it as a plugin. That's right. From an abstraction perspective, a plugin needs several things. Like it needs to say like, hey, here are the shaders that I have. Here are the resources I want to advertise. Here are the components that you would use to like attach to entities within your engine. Here's how you would want to, like, given a set of components that someone instantiates, like the wind component, for example, this is how it maps to actual draws in actual render passes. And once you define those render passes, then there's another mechanism that says, I want to hook into the rendering pipeline. Like I want to run before the depth prepass, or after the main lighting pass, or before the display mapping pass, etc. So there's some sort of like injection system there. So you can define all those in the context of a plugin for sure. There's actually an area that I'm actively working on, because while you can do some things in a plugin, you can't do a number of other things in a plugin. So for example, let's suppose you decided, you know what, I want to build my own pipeline, like for how all of materials get evaluated and lit in the engine. And I want to use variable rate shading, so to do some sort of like foveated rendering. I want to add view instancing, and let's say I want to go like all in on stereoscopic rendering, and I have a bunch of optimizations in mind for that, maybe because for me, VR is a first-class citizen. In pretty much every engine that I've ever used, in order to do something like that, you would have to like rewrite big chunks of the render, because the material interface tends to be like how the renderer talks to almost everything else in the engine. It's like very difficult to abstract. So this is something that I've been actively working on. It's like thinking about like, well, how do I take something that has traditionally been very much a black box for most renderers and make it something that a person could literally, just write as a plugin and provide, not need to do any engine modifications to provide that sort of functionality.
Yeah, that's a tricky one. So how far along is O3D as compared to something like Godot? Because that's also free, right? But I've seen some games made in Godot. They're pretty good. But how far along is O3D as compared to that?
Honestly, like, I love Godot, honestly. Like, I think there are a lot of like good aspects of Godot. It's hard for me to really compare them because I haven't used, frankly, either enough to say that I really know the ins and outs of both. Like, even with O3D, I would consider, I've been on the team for like maybe 10 months now, 10 months coming up to a year. And I have much more exposure to like the low-level systems within O3E, but and some visibility into like how it's used in a number of other cases. I know a lot less about like the architecture of Godot, like not having actively developed it, etc. So like I don't know that I can give a fair comparison. At a surface, it feels like Godot would be a fair bit lighter, like more suitable maybe for people who were doing like 1-person, 2-person teams to put together an indie game or something, or even scale up larger than that. I really don't know what the limits there are, not having shipped anything there before. O3D right now is a heavyweight engine, again, owing to its history. It's something that I think would be good for the engine to change over time, make it a little bit more approachable beyond that. But that would be like one big comparison point difference in my mind.
Yeah, for sure. It definitely seems lighter and smaller compared to all the other heavyweight engines like Unreal, Unity, other
Yeah.
O3D and stuff.
So I was looking through the O3D pull requests, and I happened upon a bindless support PR. So my question is not about the PR because it's obviously heavily dependent on O3D and technical aspects that I would not hazard to understand. However, what's your take on bindless style graphics development? And
Mhm.
is it the panacea that we've all been waiting for? Is it as awesome as because I've actually not really gone into it. We've discussed it here quite a bit, but in this group, but I'm curious your
Yeah.
take on it.
Yeah, I'm very bullish on bindless as an approach in general. Having worked with many engines that have not had bindless for a long time, there are several reasons for that. Honestly, so first of all, let's just clarify for everyone in the room, like what do I mean by bindless versus like direct binding? So generally speaking, when I submit a draw or a dispatch to the GPU, right? The traditional model said that I needed to declare up front, here are all the resources that this draw or this dispatch is going to need. So like you would have a root signature in the case of DirectX 12, you would have a pipeline layout or descriptor set layouts that are bound to a pipeline in the case of Vulkan. There's equivalents in pretty much every other API out there. And you put in your textures, you put in your buffer data, your constant data, et cetera, and then you would say draw, right? And this is all done on the CPU. So why was this a useful model? Well, this was a useful model because you can imagine that if you're a very clever driver, you can do certain things. Like I can say, oh, because I know that this resource is going to be used by this particular draw, maybe I can do some clever tricks behind the back of the ISV, the person writing the shader, issuing the draw, et cetera, and I can like hoist those resource accesses directly into the shader. I can do a number of optimizations like that. And that's actually still, technically true. So why did this paradigm shift start to happen? It started to happen for a few reasons. One, as draws, gain more resources that they need to use. Well, this is just one point. There's actually quite a big expense on the CPU side to do all that bookkeeping, to manage, what resources are needed per draw, what resources are currently bound while I'm recording draws on the CPU timeline, what changes do I need to make? So like I had this bound, I need to bind this now, right? So there's quite a bit of overhead with just the submission timeline. Another reason why bindless is coming into favor, I think, is because you have far more use cases now where when you're issuing the draw or when you're issuing the compute dispatch, you just don't know upfront what resources you're going to need. So this is the case most obviously for ray tracing, right? You cast a ray in your scene. I don't know what triangle I'm going to hit on what instance of geometry with what material attached to that geometry. So that's a case where you automatically can't use the direct bind case. You need to use some sort of mechanism that lets you access any resource that your scene graph might have loaded. Another use case might be deferred decals or terrain or any number of these sort of use cases where the resource that I want to use, whether it's a texture that I want to sample or something else, is computed in the shader itself based on some other data, right? So in those cases, you basically kind of need bindless unless you have some sort of mechanism on the CPU to compute that up front. So the last point I'll mention is that I want to say around like 7-8 years ago or so, there was a big kind of paradigm shift where prior to that paradigm shift, the thing that people were most interested in doing was they were interested in figuring out how do I get the CPU to submit draws as quickly as possible, right? Why is there overhead in JAWS? Well, I mean, you're writing commands that are going to exist on device local, like GPU memory, and the driver has to do a lot of work for that. Your function call stacks are very deep because you're going deep into driver land to basically say, I want to bind this state to this draw, etc. And so a lot of the emphasis was on multi-threaded draw submission and draw bundles and like secondary command buffers. Whenever you see these things in the API, that's what it was intended for. It was intended to improve your draw and dispatch throughput. And then a paradigm shift happened. At some point, we were like, wait, why are we doing this on the CPU at all? On the GPU, I can do culling, I can do multi-draw indirect. I have all these other techniques at my disposal to basically completely cut out the CPU from that side of the equation in general. And I think once that paradigm shift happened, again, you're seeing that like the savings that you would have gotten for like multi-threaded CPU dispatch and all that stuff, you could actually claw all that back and then some, because you could do finer grain calling, you could do two-pass occlusion, you could do all these techniques that were available on the GPU later. Now, the only caveat, though, is that if you're going to do all that submission on the GPU, again, you want some easy way of accessing all the resources that your scene needs programmatically on the GPU. And again, that's kind of where bindless comes in. So obviously, it's not a panacea in the sense that some platforms can't support it quite yet, or it's less performant on certain platforms. But I definitely think as ray tracing becomes more prevalent, as these techniques become more prevalent, more accessible, bindless will be the predominant way of binding in the future. And I think SM 6.6, if you've ever used that resource descriptor heap, that's the dynamic indexing that was released with DX12, I think in August of last year. Once I switched to that for my personal home render, for example, I got noticeably faster. I can tell like my turnaround time when I'm like prototyping new ideas or new features is just like completely night and day from before. So anyways, sorry for that super long-winded answer, but bindless is a really big topic.
You said 7 or 8 years ago that everyone's changed their minds about how things worked. That's corroborates with my understanding the origins of the Unreal 5's nanite renderer. A lot of the techniques are detailed in this presentation at SIGGRAPH in 2015.
Yeah,
By
you're referring to the Red Links presentation.
is that who was?
Yeah, there was a
Yeah,
Ubisoft
Red Links,
presentation
the
from
Ubisoft,
Seb
yeah. And it's just
Altonian.
everyone kind of went and then there's just it's gone and created its own fun worlds.
You know what's funny? I was in
multi-beneath.
that room when that was presented. This was the Assassin's Creed and how he basically decomposed this mesh into meshlets. How there was like deferred texturing in there. There was he used an MSAA trick I remember in order to like get a huge like bandwidth amplification, basically to leverage the fact that the GPU applies compression to your MSAA textures. There's a number of good ideas there. And I mean, I still have that mug from that particular SIGGRAPH conference, like in a cupboard somewhere here at home. So like I was one of those people in that audience that was like, like why am I not doing that with my current renderer? And that was one of those talks where you go home and you just think and you're like, man, I should change my approach.
So I want to ask a really newbie question because I'm a dev, very early dev, and I have some personal projects that I'm really interested in using some heavy graphics programming for, but I don't know that much about it. So if you were starting today, like what direction would you be going in terms of what you would be studying and where you would be looking at resources?
Yeah. If I was starting today, I mean, the first thing I would think about is like what it is that motivates me. Do I want to make a really pretty image, like image formation, or am I interested in empowering artists? Or maybe I'm interested in the subject matter, like whether it's the physics of surface and light interaction, or the low-level details of, like RHI driver code and that sort of submission, or maybe like low-level code on the GPU, like how does a complicated piece of silicon, like like a GPU architecture, really get like massive parallelization. Or maybe I'm more interested in the creative aspects, whether it's like proc gen, like procedural art, or other aspects. I mean, I think the thing about graphics programming is, even though graphics programming is perceived as a very like highly specialized field and specialized profession, in reality, it's a hugely broad field. Like if you just pick two random graphics engineers in any team, I can generally guarantee that they have like they may have some overlap in knowledge for sure, but there's also going to be like a huge diversity of opinions, of ideas, of things that they're good at, things that they're less good at, things that they're more or less interested in, etc. So I think I would start by trying to decide like what it is that really inspires me, and just build. Like this is one of those fields where, unlike other disciplines in programming, I've done my share of like netcode programming and physics programming and server programming and stuff. Graphics has the benefit of giving you like immediate feedback if something is going well, how well is it going? If something's not going well, how fast it is, how slow it is. Like, and that is like one of the great things about graphics, is that feedback loop. So like definitely get in the weeds and just start building stuff like once you identify anything that you're even remotely interested in. The last thing I'll say is asking for advice, asking for feedback. That goes a hugely long way. In fact, like I currently still routinely reach out to people that I used to work with, or even people that I'm acquainted with, just to like double check some of my ideas, some of my assumptions. And I think I'm going to do that for like probably the entire duration of my career and then some, just because, again, huge space, a lot of ideas out there, a lot of very, very smart people working in the field. And I always feel personally humbled by other people I work with. So definitely soliciting feedback is a good idea too.
Definitely have a particular interest in translating large data sets into visual images that people can maybe use to better understand things like the way the national budget is being used, for example, or where power is being distributed in the country. And I've kind of been floundering in terms of like, so I tried Unity for a little while to try to like translate these concepts into images, and I'm a little bit stuck in like where to start with what kind of programming knowledge I need to be able to kind of get my head around these things conceptually. So do you have any ideas for me about like what to look at specifically in that area?
So it's interesting you mentioned that, because like data visualization is an entire art unto itself. Like one of my favorite books is a book from Edward Tufte, who is actually a data statistician. And one of the books he writes about is about visual design and the dissemination of information. Like one of the big ideas I remember he wrote in that book is that you want to maximize the utility of all the ink on a page. So like if I had some way of measuring the amount of information that the page is conveying, and I divide that by the amount of ink that I used to create that visualization, that ratio is in effect like a measure of the efficiency of how well I convey that information. I think from a programming standpoint, it's a little bit harder to answer that question, because data visualization of large data sets is very broad. You could be making plots in ggplot using R as a language, or like you could be using GNU Octave or MATLAB or Mathematica. I use a lot of different tools depending on what I'm trying to do. So one of my favorite tools, for example, is actually an online plotting tool called Desmos, which I use to like visualize small waveforms and functions and stuff. Other times, I'm writing tools from scratch because I need a way of visualizing, I don't know, how probes are distributed, like how the probe density is distributed around the level, to understand like maybe why I'm seeing a lighting artifact in a particular area. In terms of like where to start, I would just say pick a thing, what it is that you want to create, and maybe maybe if you ask with that specific thing in mind, either folks here or myself would be happy to try to point you in more of a direct direction. Because I will say for a lot of those visualizations mentioned, you'd use a different tool for each one of those jobs. In graphics, most commonly, like if you're actually building a graphics technique, you'll generally be running a debug shader, debug render passes, debug pipelines, debug buffers, UAVs. You'll be doing a number of those things in order to visualize what it is that you have created. And for that, you just need bread and butter graphics programming knowledge. Like you have to know what a vertex shader is, you have to know what a pixel shader is, you have to know what a render pass is. A lot of those things you can get from introductory material on like, just the graphics pipeline in general. Like it doesn't have to be anything super fancy, like just getting through a tutorial on like roughly how a triangle gets on the screen and how you texture the triangle and how you move it around and everything. Once you have that, it's just a matter of layering more knowledge on top of that to build something a bit more complex.
Um,
I would actually really love to connect to talk about this more specifically, because I actually do have a project in process that I've sort of put aside because I think I'm missing a key piece of knowledge. So I appreciate that offer. Thank you.
Yeah, feel free to DM me or anyone else here, I'm sure.
Yep,
It-
confirm.
you mentioned low-level architecture earlier, and that's what I'm interested in. And I've found that there's been like literally no examples out there that I could find for something like a GPU assembly, because they all hide it from you, and the lowest level they give you is something like Vulkan and stuff. Ideally, what I'd like to have is a bunch of examples of different uh, graphics card assemblies. Then I can get an intuitive sense of what they all have in common. Then I can really understand the graphics APIs from the bottom up. But do you have any suggestions where I can find something like this?
Yep. If you truly want to go off the deep end on like the super low end stuff, there are actually two really good resources that I recommend. One is the AMD RDNA white paper. So I can link that to you if you haven't found it already or if you haven't seen it. But basically, AMD has for a while now, it includes GCN, that's Graphics Core Next, which was the previous architecture before RDNA, and now RDNA 2 has been out, and there's another paper for that, and now RDNA 3 is coming up. And I'm sure when that's released, there'll be a white paper for that. So compared to NVIDIA, where for NVIDIA, you do need to be part of like more of like an NDA kind of like, lockdown program in order to access those architecture documents, AMD just exposes it. More than that, AMD has a really high quality open source, Rad5 driver. If you look at the Mesa, that's MESA driver for Linux, a lot of how Vulkan is implemented on their driver is there and just open source and public. If you want to know like what is a memory barrier doing, or what is like how does Vulkan handle resource transitions, or like what is it actually doing when I say VK command draw in instance index, or like any of those things, you can actually just look directly there. Synchronization, fences, it's all there for the most part. So that will cover the driver part. Is that just looking at the open source driver? If you want to understand how the driver functions, that's a really good proxy for that knowledge. And then for the lower levels, like the architecture stuff, I mean, short of working on the GPU itself, like you want to work at like Apple on the M1 chip or AMD or NVIDIA on the actual chipset, I suggest the AMD white paper. If you want to look for jobs that will get you even closer to the hardware beyond that, definitely look for jobs that have console programming in that job description. It can be something that like if they support console programming at all in that particular studio, then you will naturally get access to additional documentation, additional resources that are like dedicated to how a Sony console or how a Nintendo console or how a Microsoft console will function.
So how I'm thinking about this, maybe it's wrong, but what I'm thinking is how the GPU works, where you can write some assembly and you can actually visualize the assembly code being zeros and ones. Then from there, you can really easily understand how that could work if you know the architecture, the hardware architecture, how it works on the GPU, how the electricity even really flows, right? But I don't see like a assembly that I can write in for graphics to get that kind of understanding. So am I thinking about this wrong? Is that the
Well,
problem?
that will give you one picture for sure about how it works, like in terms of like the instruction set. So like there's GPU is a hierarchical chip, right? Much like the CPU is, meaning like you have your individual shader cores, which are running multiple threads in lockstep. Beyond that, once you have like L1 cache, you have a number of cores operating together. They're sharing like LDS, and those things flow. And then you have to think about like, well, how does that talk to the bar, and how's that access memory push over the PCI Express? And you can see there are many actually different components to the GPU, and the instructions that you write target like one particular aspect of how GPU works. Now, that said, if you're interested in the ISA, there is a tool that you should use, which is the Radeon Graphics Analyzer. So again, compared to NVIDIA and other chipsets, AMD cards actually let you inspect that assembly in that ISA. So, for example, if you load up in PIX, if you're running on an AMD card and you load up in PIX and you take a frame capture, if you run analysis on it and you inspect your a given draw or dispatch, and you look at the shader that's bound to the pipeline there, you can actually see all the instructions compiled down to the AMD ISA. And those instructions, like what those instructions actually do, like shuffles and gathers and etc. Those all are described in the white paper that I mentioned at the beginning, so you can actually see that directly. If you don't have an AMD card, they actually provide a tool for doing this offline, which you can use to right now it actually only works on GLSL, which is kind of annoying because I use HLSL primarily, but you can type in shader code there, and they'll just compile it to the ISA for you, so you can inspect it, even if you don't have an AMD card installed. So if you don't have AMD, that's your route. The last tool I'll mention is ARM has a tool referred to as the Mali Offline Compiler, MOC for short. You can compile shaders there, and it can do things that are like not quite taking it all the way to the ISA, but it will be able to show you things like cycle counts, and it will run effectively machine code analysis simulation on your shader and expose some information, some additional low-level counters and information. Simulated, obviously, but still better than nothing.
Cool. Can you send those tools?
Yes, I will link. I'll just take a note of them here
I
on a
think I
paper.
found the RDNA white paper. I mean, I
Yep,
just
I got
Googled
that.
it.
that's
I
already a
also
white paper. It can be instructive to even read the GCN white paper, which came before, but which has a little bit more information actually that I found than the RDNA white paper, and some of those concepts map over. Yeah, what I'll do is after we go through like this Q&A or whatever, I'll put together a whole bunch of like links that I think might be of interest to the folks here, and just dump them all in the channel.
so
Great. Thanks.
so following along that line of discussion, how did you get into systems programming? I see on your website you describe yourself as a systems programmer, and I've somehow found myself in that rabbit hole too, even if through odd circumstances. How did you go about learning what
Mm-hmm.
systems mean? What was your experience like getting into programming and then going to the rock bottom of it rather than
Yep.
staying in a working at a very user-facing, end user-facing role like a lot of web dev and UI people are?
Mm-hmm. Yeah, this is a funny thing. I think ultimately most graphics engineers at the end of their career will find that they know all sorts of things about, I don't know, Win32 programming, about memory allocators, about paging, about kernel mode and user mode, like all these different concepts. And I think the reason for that is because the systems that we write use so many resources that a lot of bug reports come up on my desk, even if they have nothing to do with graphics. I'll give like one example. I remember like one of the first bugs that I solved ended up having nothing to do with graphics, but it looked like it happened with graphics because it was a memory allocation failure, right? So if you have a memory allocation failure, it's not necessarily the fault of the person who happened to allocate memory at the very end, right? Like, what if I just happened to be allocating memory and we already had exhausted like all the available memory on the system because some other system was doing it? And just the renderer, because it happens to need to be allocating a lot every single frame and just doing a lot of stuff, generally speaking, that means that the surface area of the renderer to like the rest of the world is just naturally going to be broader. And so I want to say that even though I did a lot of work in graphics, in order to like bootstrap a renderer yourself, like I feel like the baseline, like the skill floor can be very high if you're not willing to like use third-party dependencies and other frameworks that make things easier for you. I will say things are a little bit easier now, but before, like you had to know how to like write an allocator and do like all these other tasks that were generally lower level than you do now. Now you could potentially take an off-the-shelf dependency like the Vulkan memory allocator or the D3D memory allocator that AMD has released. But I'm thinking like prior to the DX9 days or whatever. Like the interfaces and like the programming practices and everything were just not as convenient as they are now. And even if you go in now, you know, graphics APIs in general have gotten a bit more low level. So ultimately, either way, you're going to end up being exposed to those concepts just in the course of your day to day. There's one other angle I'll say too, which is that like a lot of graphics engineers that I know happen to know a lot of like random knowledge about like compiler design. Like people know about lexers and parsers, obviously like grammars and general like optimization principles, people like constant folding. Why? Because shaders are a huge part of the graphics programmer's like lexicon of skills, like understanding how that shader compilation pipeline works, because ultimately you are writing programs that need to be compiled and dispatched to the GPU, and like how those programs get compiled does play a significant role. Like not necessarily for every graphics engineer, but generally you will get some exposure to it at some point.
Something debugging shader compiler drivers, shader compilers, something. Goddamn OpenGL and GLSL.
Yeah. And like every now and then, like if you look at like the DirectX shader compiler, for example, you'll occasionally see issues filed by me, filed by people that that use it, like other people that I've either worked with before or currently work with even. Like it's a very interdisciplinary field. Like there's the art, there's the physics, there's the math, there's the low level programming, there's the compiler stuff. And again, that's why like it's a specialized field, but at the same time, it's like you're kind of a generalist too at the same time.
I was hoping to ask kind of more from the career side of things. If you have any kind of general advice for people looking to transfer or transition into graphics, like especially from non-graphics dev roles.
Mm-hmm. Definitely building a project helps the most, I think. Ultimately, like a lot of people in the industry, even people that I know personally, are honestly very interested in taking on people that are maybe a bit more junior in their career, or if not in their career, maybe even a bit more junior specifically in graphics, and they'd be willing to mentor people that either show promise or show motivation or just a general interest in it. Having that project definitely helps the most, because getting started in honestly any new thing, whether it's graphics or a new instrument or a new language or whatever it is the hardest part. So if you build something, then that's probably the best thing you can do for yourself. Beyond that, there is a standard like body of books and literature. I do feel like many graphics engineers will tend to like eventually learn over the course of their career. What I would say though is you should just keep on learning that stuff on the side. But if you're truly interested in the field, try to get a job. Like you don't feel like you have to know all of that stuff before you go into the field and start working. I've worked with junior graphics programmers or mentored them where they were fresh out of college and knew some C++, but not much more beyond that. And that was totally fine. Like they were willing to put in the time and they had the motivation, like the grit needed, I think. And this isn't to scare people away from graphics in particular. Like I always feel like graphics programming sometimes gets that rap where it's like, oh, like you just need to work like 40 hours a day in order to like make a dent in the field. I think graphics is more about consistency. Like, it's something where you do constantly need to be learning year in, year out, because the field just changes so much. It doesn't mean you have to burn yourself out in year one. It just means that you should expect that it's going to be quite the journey. And for most of us that are in the field, that's what makes it so rewarding and just so gratifying. Like, one, you get to master a subject and a collection of subjects. That's super interesting. And two, the results that you ultimately produce off the back of that expertise and knowledge really speak for themselves.
Cool. Thank you. Yeah. I guess also maybe jump in with another question. I'm curious with your work on the O3D engine. One thing I've noticed with my own projects is that maybe especially as a beginner, that the more I try to abstract and generalize, the worse I find my end result gets, and it's a lot easier to just focus on the use case and make sure that is optimized for. I'm curious how you approach working on such a general engine where you maybe don't have that specific use case in mind, and you need to keep it open to like a variety of different use cases.
Yeah. Oh boy, is that difficult. I mean, I'm one of those people where if I am doing something for the first time, I actually completely go in with the mentality that the first attempt that I have of making an abstraction for it, I'm going to completely throw away. Like, I just completely psychologically prepare myself for the fact that, like, my first attempt or even my second or third attempt will be just a failure. But a failure in a good way, like a failure in the sense that I've now learned something that won't work. Now, what's important about that mentality is it means I'm not going to be like emotionally attached to what I have. It means I'm not going to like go out of my way to like make my initial attempts like squeaky clean or something like that. It's more about like, how can I get a prototype together, a vertical slice that gives me as much information as I can get about the problem domain? Like, whatever that problem domain happens to be. Like, am I trying to abstract how texture streaming is going to work? Am I trying to abstract the mesh ingestion pipeline? Am I trying to abstract the material system, shader asset pipeline? Like, in any of those like different facets of how a renderer works and how a renderer integrates with the rest of the engine, I just imagine this giant state space for what the problem space looks like. And the first few attempts is you're trying to explore or cover as much of that state space as possible and figure out where the trouble spots are. And then you can say, okay, now with all this information I have, let's go back to the drawing board and what does attempt 2 look like with this newfound information? With rendering in particular, one really good thing that you have at your disposal generally that you should always use are artists that you work with. Early on in my career, and this is actually a really good segue back to that original question, like what I would do if I was getting started. I think some of the most influential things in my career have been shadowing artists. Like, I'm not saying a word, I'm just sitting behind them, and they may be talking me through things, but like I'm just generally seeing how are they working? Like, how are they putting together an environment? Or how are they spinning and rigging a character or applying a material to a set piece? Like all those different workflows. How are they putting together a fire or smoke effect on this spell or something like that? You learn so much about the customer there that you wouldn't really get just by coding it, if you know what I mean. So I think those things in tandem generally mean that you will hopefully eventually converge on a good abstraction. And simplicity is generally key. Like, if there's any question in my mind as to whether an abstraction is good or not, like it's maybe I'm like 70% sure that the abstraction is good, I generally don't build it. I generally opt to wait and be a little bit more conservative, because you can always build abstractions on top of the lower level stuff, like simpler concepts that are easier to work with. Like, the moment you add complexity early, it becomes very hard to untangle afterwards.
That makes a lot of sense, and that's very encouraging to hear. Thanks.
Yeah.
So Slylips asked a question in the general chat. Should we, it was referring to the types of projects you should do to get into the graphics field. Should it be a larger project or a series of smaller projects to demonstrate your knowledge?
I would go series of smaller projects personally. I mean, everybody is going to be different, and I think some people will take the big ambitious project and just go like, all the way, soup to nuts, just build this like perfect abstraction and have like a full rendering engine at the end of the day. I think that's possible for sure. I think far more likely, though, is that a person who's learning will build kind of a toy renderer that has some capabilities, like, you can get some meshes on the screen, it can get it textured, etc., and rewrites it or does it again or does it differently. Or I could see a person writing that first pass and then deciding, you know what, I'm actually more interested in the lighting or the material workflow, like, pretty pixels, shader, tone mapping stuff. And then from there, they'll kind of fork into that direction and focus more there, where they don't feel like they need to work in the RHI level as much, or like, the CPU side of the render, and they'd rather focus on like image formation or some other particular problem. So I think the danger of going too hog wild with like a super big, ambitious project is that you don't necessarily know what you actually like and don't like yet. And it also requires much more staying power and doesn't give you as good of a signal about the project early. Like, it's harder to show incremental results with that. Again, though, everybody is different. Different people are motivated by different things, and so like I just encourage people to generally be introspective. Like, what has worked for you in the past? Like when you got into something and you wanted to learn it and you wanted to stick with it and you wanted to get gain proficiency in it. How do you operate? And just dangle the carrot for yourself, so to speak.
Yeah, but that tracks with my mental model for how to approach this stuff. The idea of failing fast comes to mind. You'll see this in game design and maybe film project style discussions, but learning that you're going to fail eventually, learn where you're going to fail early on rather than sink 10 years into something that and eventually fails or doesn't meet your
Mm-hmm.
expectations. So, like you said earlier, learning to not, what is it, fall in love with your code, being able to throw things away. It's very freeing when you're not stuck in it becomes a sunk cost fallacy
Mm-hmm.
when you start working on in my opinion, it becomes a sunk cost fallacy when you start working on big projects, especially as a beginner, new person trying to learn new things.
Mm-hmm. Absolutely.
I
Some
like to find placeholder graphics that I don't like, that I know that I don't like, because it helps me not to become attached. So if I do build something that I'm finding, to be interesting, I still have these ugly graphics that I know I'm not going to want to keep.
Oh
So I
yeah,
don't know if
for
that's
sure.
helpful.
Yeah, I recommend doing that. I recommend saving a lot of screenshots of your
Oh,
successful
yes.
and failed attempts. Like, that's one thing that I love doing. Just seeing how many bad attempts I had at trying to solve a problem can also be very motivating, at least for me.
I love bug screenshots. You just can't make that stuff up. Like, you can't plan it out. They're just so crazy and wild looking.
Yep. I think I have a few on my Twitter. Let's see if I can try to find some. Yeah, like I had this one, for example. I was playing around with something. This was in my home render, and it looks horrible because there's a memory corruption bug. And I had resurrected an older project, and I was adding ray tracing to it. So you can kind of see, like, I'm gonna run into this sort of nonsense all the time, where like I've made some catastrophic error that's horrible, and then you just work it through and fix it. Um, I think I even mentioned actually in one of these tweets that I want to normalize people sharing their failed attempts, because it's really easy to look at work done by people who were like very impressive, and they are very impressive, and just sort of imagine that it was a very linear path for them to get to where they were. But I guarantee you that on the way there, they were banging their heads on like one bug for like hours, days, weeks, however long it was. Or there's sometimes bugs that just linger for weeks and they just can't figure it out. And it just takes like one moment of clarity before you realize what's actually going on. So, yeah.
So in the graphics programming Discord, which is a different Discord than the one we're in right now, there
Mhm.
is the Bug Collective channel, and it is a place for people to post the pictures of the bugs they've found in their graphics programming adventures. And it's just fun to
Awesome.
scroll through it and see all the weird things that you get when you don't do things quite right, but you don't know how it's wrong just yet because you haven't
Yeah.
fixed it.
Here's another funny one. You got some I'm GUI textures and like the previous swap chain like all over the scene. So speaking of bindless, this is what happens if bindless goes wrong. Like you have like an indexing problem and you're not actually accessing the resource you think you're accessing.
One of my first weeks using OpenGL, modern OpenGL, I somehow bound the frame buffer to the texture I was trying to render. And so I had like a recursive scene where the box had the scene inside of it, which had itself inside of it. It was just lovely. And I don't even know how I did that as a
Oh yeah, it's like if it was like OpenGL or DX11, like usually I would assume that was something like stale state that was bound to the graphics context that didn't get like unbound somehow. But
I had so little experience, I barely knew what I was doing, let alone what I was doing wrong.
yeah.
Hey, so I have a question.
Mhm.
So in your professional capacity, how much time do you spend just like reading up on graphics papers and trying to implement them? Because the most recent one that I've been like enthralled with was like the Reister one, like the spatial
Mhm.
temporal one. And I looked at it, and I thought like every engine needs this, right? Like this is huge, or am I just wrong here? So I'm curious, like how much time do you spend like just looking at graphics papers and seeing if it's worth implementing?
Yeah, I mean, speaking of Reister, I actually like wrote a little short blog blur where I mentioned it here. I, I do spend a lot of time reading. I hesitate to like necessarily like say a number because I don't want to scare people. But I definitely read at least 2 to 3 papers a week. And it's not like the same quality of reading because usually when I'm initially reading a paper, it doesn't take me that long because I'm just trying to figure out like what are the main ideas of the paper. Is it something that I think I could see more broader applicability or usage? And then if I commit to saying, okay, I want to actually, do something with this paper and like maybe even implement it or something like that, then it goes from like a 1 hour, 2 hour commitment for that paper to like a week, 2 weeks, or longer. One example of that was I had like earlier this year, for example, this was actually, I haven't had very much on the blog recently, but these just happened to be the 2 most recent ones. I had read the flip paper, and the flip paper was something that had been released from NVIDIA much longer before I wrote this blog post. But this is something where I was like, oh yeah, this would actually solves a practical problem that I have, and I had remembered that I had read that paper before. So let's just go back to it and revisit and try to implement it, see if I like can test my understanding of the paper. In this case, they actually provided source code, which was useful in one case where I had like a bug and I had like no idea what I was doing wrong. And it turns out I had like misunderstood like one aspect of what they said. Um, Currently, I'm super interested in applying the restart paper to my own GI solution. So that's something that I've been prototyping with. And I've also really liked the Surfel-based like Gibbs formulation that EA Seed had presented at SIGGRAPH last year. Long-winded answer, but basically, anytime something catches my interest, I'm just reading it. Like that's really all it comes down to. And unfortunately, in graphics, or fortunately, depending on how you look at it, I think interesting all the time. Like hardly a week goes by where I'm not exposed to some new idea that I just want to get more exposure to and like try to understand in some way, shape, or form. Um, but I will say also, I don't feel like I'm in any danger of burnout or whatever. Like this is just genuinely purely of interest. I will also say not every person needs to, be this prolific of a reader to necessarily be successful in graphics or anything like that. And I know plenty of people that have a much stronger separation between their work life and their home life, if you will, than I might. It's just a matter of how interested are you, how accelerated do you want your learning process to be, and everyone knows themselves the most. So definitely don't burn out. But like, if you see something that's interesting, just latch on.
I want to add to that. We are always open to covering papers in this meetup group. If you have something you want to read and present to the group, great. If you have something you want to just have a group reading session on, that's even just as great. I've had plenty of fun and learned a lot reading various resources with everyone here.
Yeah, I think it's a great thing to do. And what I've learned from this group that I didn't know before, after joining all the meetings, is that everybody is really comfortable with not knowing certain parts and not understanding certain parts completely of
Hmm.
whatever it is. I I'm still fighting with that, to a degree, and it's just awesome to see that people can kind of just leave that as a variable, like maybe X, we'll solve it later, and then get to know the rest of it, um, and then iterating like that over and over. Each time you go through, you'll know a little bit more. Some more variables will be solved, as opposed to kind of have to adamantly insist that every part is understood as you go
Hmm.
through it. I think that's something very valuable that I learned from this group by
Hugely
reading the papers.
valuable. Like I can't think of a better like way of, ensuring your success than to be just very comfortable with not knowing something in the present. Um, like honestly, like when I interview people, even like when I interview prospective graphics engineers, usually you can pick out on that a little bit more. Like people who are just not comfortable knowing. Now, obviously, that's in an interview setting, and maybe like the person's experiencing pressure or something like that. But like, I will say that candidates that like generally are more forthright or more comfortable with like knowing where the limits of their knowledge are, they're just a bit more comfortable to work with. And I view this not just for like interview candidates that you interview, but like people that you work with, people that you collaborate with, etc. I think you have to start there.
And I think what that requires also is consistency, that you come and revisit the parts that you didn't understand daily. I mean, if it, I found that if I don't do it on whatever it is on a daily basis, it just loses potency over time, and then it just fizzles away. So maybe like an hour a day at least. It's kind of like playing an instrument. Like you don't use it, you lose it, type of a thing. Um,
Yeah, and we can actually take a page from like how various subjects in school are taught. Like if you think about like say math, for example, you get exposed to your initial course in algebra in middle school, maybe, or early high school or something. You get exposed to it again in like algebra 2, then you get exposed to it again in pre-calculus, and you get exposed to linear algebra. If you take more math courses beyond that, then you're looking at abstract algebra, and then abstract algebra 2, and then commutative algebra. And then like you go to grad school for math. I didn't go to grad school for math, but if I did, again, I would be taking a graduate level course in algebra. And like that's true for algebra. That's true for electricity and magnetism. That's true for mechanics. That's true for like pretty much every subject that's out there. I think in reality, almost everything, every concept that you encounter, whether it's in graphics or otherwise, you just need to encounter many, many times in many, many different contexts and situations to really like understand it fully. And I will say, like, probably for everything that I know, I don't know it fully. And I will need to revisit again from a different lens and constantly think about it or talk with other people through that problem to, gain another insight or another angle that I hadn't considered before.
yeah, it's um, it's easy to kind of say that, but it's hard to know it when you're in it, and when it's new. It's not something you do every day. To do it, it really demands like a lifestyle change, is what it is. You have to spend your life in this if you're serious about it.
I I want to counter that and say yes, but once you start doing that, you won't notice that you're doing that. You won't feel you won't wake up someday and realize, huh, everything is different than yesterday. It will sneak up on you that you're already doing the things that you thought you needed to do. And so it's just kind of a weird state of being that you can't just turn on. But it happens. And you can only really tell in hindsight that you've gotten to that point.
Yeah, I mean, generally what I've seen is that people will get discouraged, not so much if something is hard, but if they perceive that they're no longer really making progress, like you just get stuck for too long a period of time. And like one thing that makes self-teaching particularly difficult is like, unlike circumstances where you have a teacher and you have assessments that give you feedback, etc., like there's no one really telling you what the next thing you learn is when you're self-studying. And furthermore, if you self-study and then you learn something actually wrong because you like misunderstood what somebody was saying, or you like misinterpreted a result or something, there's no one that can like, that stands over your shoulder immediately and just says like, hey, like I actually think you need to revisit that concept. So knowing those two things, though, you can put yourself more at an advantage again. You can say, okay, what are the baby steps I can take in order to make more incremental progress? And like, how do I track that and use that for myself? And furthermore, you can say, okay, when I'm learning things, what are the mechanisms I can put in advance to check my understanding? Like, and that could be, didactic, something that you do yourself too. Like if you learn something about matrices or something, that there are things you can do just on pencil and paper to verify your understanding. But in other cases, you can involve other people, like the people in this community, for example.
I've had a thought before to try to put together like a trail of papers that go from like simple to hard, and just like work through it over time. Because I found that the motivation thing is important to complete something, and if you can kind of find like an easy paper to implement that maybe within a week you could do that's what I'd like to find right now. I haven't spent too much effort in looking for that. Like Leslie had this grass thing program that he wrote that followed this paper. I started looking at that, and it's just like really discouraging. I don't think that's something I can do within a week. But maybe do you have like a suggestion for a paper that's like simple to start with?
I mean, let's see. Assuming you've got the basics of like, I don't know, even like a Phong shading model or something like that, just something really basic. Like I think shadows are a really good concept. Like a basic shadow map doesn't have to be cascaded shadows, doesn't have to be any like exponentially spatially varying shadows or VSM or any complicated version of shadow mapping. I just mean rendering the geometry from the perspective of a light to texture, sampling that from a different texture, and like no filtering or anything like that, and getting a shadow. Why is that an interesting starting point? I think for a lot of beginners is because it can branch out heavily from there to all sorts of different techniques, some of which I've already mentioned, like exponential shadow maps or variance-based shadow maps, moment-based shadow maps, which are an extension of variance-based shadow maps, virtual shadow mapping, which is something that like Nana introduced, for example, ray trace shadows with denoising. You can basically take one concept that started as a pretty like modest idea, and then you can go any number of directions with it, just depending on like what aspect you're a bit more interested in. Like, so if you were more interested in like the more like Monte Carlo style denoising type things, you could take your shadow code and you could literally just use trace inline ray and write ray trace shadows in a pixel shader if you wanted and try to denoise that result. Like there are many different things you could try and do.
I see. That makes sense. Thanks. And there's a lot of suggestions in the chat also. I think they're all really good.
Yep.
Thanks for the suggestion.
Yeah, I mean, image-based techniques are really good too. Like if you haven't implemented just something like an image blur, like on a GPU. Like it sounds like a really mundane task, but I think most people would be surprised at how deep you could go if you wanted to do that really efficiently. More than just efficiently, if you wanted to support different kernels and different filtering methods and different means of accelerating them. Like, obviously, or maybe not obviously, but in some cases, the kernel is separable, like with a Gaussian kernel, for example, and you could try doing that and implementing that, verify your understanding that this actually works. For the kernels that aren't separable, like thinking about how memory gets accessed on a compute shader, like and swizzling that properly, verifying in a profiler that the linear access is in fact slower then the swivel axis and seeing the hardware counters that demonstrate to you why that is the case. Like, there's obviously a lot of these things are easier with a mentor, because right now in the conversation of this chat room, you have me telling you like you could try this and you could do this, but there are many projects like this where you can take a simple concept, like in this case, image blurring was just an example, and it's a very, very deep rabbit hole.
Yeah, totally. Everything can start simple and then go very deep.
Yeah, anti-aliasing. I mean, like, I don't want to scare people, but like, there's this. That's what I find really fun about the field, is that there are people out there that know more about any one of these topics that I'm telling you guys about than I ever will in my entire career, and that's okay. Like, it makes it interesting. It means that there's more for me to learn. If I wanted to get into one of these areas, there'd be plenty of stuff for me to read up on and do. And you know.
Fear not the man who has spent who has spent an hour studying 1,000 different blade techniques. Fear the man who has spent 1,000 hours studying one blade technique.
Yeah, definitely getting good at a few things is definitely preferable, I think, on average for most people, than trying to, like, putz around with thousands of things.
I mean,
Not universal, but what I've
the
noticed.
I've heard of the T model of learning, where you should have a broad understanding of many things. A broad meaning you know many things, but you only know it a little bit. And then it's fine to have a one thing that you just focus on, and that's like, hey, I just want to do this, and you get better and better and better at that one thing. Um, I've heard this in talk about PhDs, where a PhD should have a broad a good understanding of many things, but they focus on one thing for many years at a time.
Yeah, and then eventually they become a comb, I guess.
Oh yeah, that's a good analogy.
So,
Sorry, go ahead.
yeah, I'm curious about your work. So, can you go through like a daily, one day? What do you do? Like a week, maybe like map it out. What's like?
Yeah, I mean, so my position currently is a little bit different because I'm doing a bunch of stuff not directly related to graphics, and also related to other groups that are using the rent. Like, I'll give you one example: is this open source project, for example. Being open source, you don't really want to include dependencies on things that are not open source. And one of those dependencies that we need is DirectX, like the DirectX runtime, which historically has shipped with the Windows SDK. Now you're expected to release a redistributable. That's an Agility SDK that they announced sometime in like August last year or something like that. But I have to figure out, because I'm also the chairperson of the technical steering committee, like, how do I integrate these dependencies, including like NVIDIA's Aftermath and other things, in such a way that we can require that users accept those licenses and incorporate as part of like the build process. This has nothing to do with graphics, really. It's just a problem that I happen to need to solve because I needed the new Agility SDK in order to access shader model 6.6 and 6.7 features. So sometimes that will happen where you kind of just get context switched because you want to solve a problem, and to solve that problem, you have to solve a different problem, and to solve that problem, you have to solve a different problem. Today also, I was in a number of design discussions specifically. So O3DE currently does not have a material graph system. Like, that's something that you would use, that artists would use to like prototype new materials and more like procedural style shaders and stuff like that you can use to like visualize very quickly. And so that's something that there was a lot of customer demand for. So something that the team committed to building early this year. I've built that once before, and I've made a lot of modifications to a different version of that in yet another engine. So having that experience and then coming in with fresh eyes to this engine in particular, I was able to work a lot with the engineers that are working on that system to try to like help guide them a bit more. But you'll notice that, like, in my current role, there isn't going to be as much like raw implementation day to day that like a typical junior, mid, or senior engineer that was like embedded in this team would have. On some days, I will get to code more. Frankly, I wish I could code way more than I currently am coding. Like you saw that bindless PR that I put together, for example. Like I just whipped that together in a week or something just to get an initial prototype implementation going. That's going to be maybe once every 2 weeks. I'll get to really dive down on a hardcore coding problem. A lot of my other time is spent more in the design space, more in the architecture space.
Yeah, that makes sense.
That's why I do all my coding on the evenings and weekends, because I miss it too much.
So I have a question about finding the opportunities, like not actually getting the job, but like finding what's out there. So you said that you're like relatively well, you joined about 10 months ago. So like the way that I've been looking at opportunities, like I would just go onto LinkedIn and like search for like graphics engineer or like rendering engineer. Is that like how you would go about finding the different opportunities out there? Because like honestly, like when I look at that, like I see a bunch of like AMD, NVIDIA jobs, a lot of like driver levels.
Yeah, honestly, what I would say is get your project together, get your resume, etc., and just cold message people on Twitter and LinkedIn.
Okay.
And you'd be surprised. People in this industry, like, there are people that are like maybe not welcoming to that sort of thing, but in all seriousness, I know so many people in the industry that are like genuinely interested in helping people. Like, even if you're not a great fit for their particular team or whatever roles they happen to have open at the time, nobody looks at a person that says, hey, I'm just looking for some advice. This is what I have together. I would love an opportunity, but like if that doesn't work, do you have any feedback for me on like how I should best focus my time and effort in order to learn more? Because this is really what I want to do. This is what I'm interested in. Like, I have to believe that you will get a great response from people like me, people that I know in the industry that are very well regarded, rendering leads of various teams, etc. If an opportunity doesn't work for their team, many of them would be willing to refer you to someone else. So I definitely recommend going that route. Like, obviously, you can submit your resumes to the void that is, just job sites and job application sites and stuff. Those generally get fielded by a recruiter or someone else in the hiring pipeline, where some of those ideas I just mentioned in terms of like contextually what it is that you're after, like what are your career aspirations and goals, like who do you want to be in 10 years, those are potentially lost on the individual who's handling not just your resume and cover letter, but like that of possibly hundreds of other people, so I recommend the personal touch. Just like worst case, they don't respond at all, but that's you miss what is it, 100% of the shots you don't take, or something like that, right?
Okay,
So-
yeah, that's pretty good advice. Thanks.
Well, I want to say something on that is I found that a lot of programming jobs, as far as freelancing goes, those opportunities are given by other programmers who aren't necessarily graphics programmers. And what they're looking for is somebody who's good with graphics, but then they themselves are already a programmer, as opposed to something like game programming, which is what I do mostly now. Is that the opportunities will be provided a lot of times by designers, by artists that cannot program games, and so I feel that in terms of graphics programming, it's more of a discipline, a subset in programming. So a lot of times, what you meet, the people that give you the opportunity are actual programmers themselves, and so but the opportunity can be also looking for freelance jobs over at say Upwork or Fiverr, so as such, and you can like build slowly in that way. And so the last week's presentation that I gave on OpenXR, that was one of the jobs like that. The reason I got into that specifically is because the client wanted something like that, but then in the end it didn't work out. He didn't like it, and he didn't pay me. And so, and we were negotiating between like some kind of price, and that is partially the payment of the whole thing. But I decided just not to take the payment, and it became mine, so that I can share this because it's mine. And so the opportunities can come that way. And I've gotten a lot of OpenGL opportunities also, but a lot of them are like over my head. And but this one was also, and so that is a good way to do it, in my opinion. Also,
Yeah, for sure.
I think social media is a
I
huge.
think if you want to have, sorry, go ahead.
I was just gonna say, I think social media is a huge resource for that kind of thing. You know, being able to you know, get in touch with people that you know, you wouldn't run into in your daily life and things like that.
That's when it's handy to have a lot of projects that you've done in the past to show, right?
Yeah, I think
Yeah,
so.
it can
Yeah.
definitely be healthy or like good. I mean, I think people would be open to asking questions like, I forget, there's the lead on the Fable rendering team, like Interplay of Light. He's really active on Twitter, for example. He'll answer questions from anyone. Like I'm the same way. Like I have my DMs open. People ask me questions who have never written a line of graphics code in their life, and I'm generally more than happy to take some time out of my day to answer questions from people that are genuinely interested. Because frankly, our field is far too small for the amount of work and interesting work that there is to go around. So it's always a pleasure to help introduce a person into the field. Awesome. Well, I will probably call it at this point and get some dinner. But I do want to just say I really appreciate everyone having me. I thought people here had excellent questions, excellent insights. I think people are doing impressive things also, like what you guys are trying, or what you guys and girls are trying, what everybody's doing. It takes a lot of motivation, a lot of effort. I totally recognize that. If people have questions, you're more than welcome to DM me here on the server. I'll try to make sure like I have Discord open from time to time. Obviously on Twitter or anywhere else as well. You can feel free to reach out.
Thank you for spending your evening with us. It's been a lovely time.
Yeah,
Thanks a lot. This has been
thanks so much.
fantastic.
Yeah, thank you.
Yeah,
It was
thanks.
tremendously helpful. Yeah.
Awesome. All right, everyone. I hope everyone has a good evening.
Have a good night.
Good night.
Good night.
Thanks. Have a good night.
So we don't normally end right after the presentation. You're free to leave whenever. Now we just kind of have fun and talk about stuff that's happened in the week, whether it's something you've worked on, something you've seen, something you want to share. It's pretty much a free-for-all.